In this video, we want to discuss two of the major types of chemical compounds. So just a quick review, matter can be divided into two major types. We have pure substances and mixtures. Pure substances can be further divided into elements and compounds. Elements are substances that are composed of only one type of atom throughout, and we represent those with an elemental symbol. Compounds, however, compounds are composed of two or more different elements that are chemically bonded together. And we represent chemical compounds using a chemical formula. So we want to focus our discussion here on the types of chemical compounds. And there are two major types that we want to discuss here, which are ionic compounds and molecular compounds. Let's start with a brief discussion of ionic compounds. Ionic compounds are formed when in chemical reactions when a metal atom or atoms loses one or more electrons and a non-metal atom gains those electrons. So we have a transfer of electrons from our metal atom to our non-metal atom. The metal atom, since it loses electrons, forms a positively charged cation, and the non-metal forms a negatively charged anion. Now, of course, we can recognize metals and nonmetals on our periodic table because metals tend to be over on the left side and the nonmetals tend to be over on the right side of our periodic table. Now, once we form these ions, the ions, of course, have opposite charges and they're attracted electrostatically, which means they're attracted based on opposite charges. These opposite charged ions, when they attract to each other, they form an ionic compound. The ions in our ionic compound are held together. This electrostatic attraction is what we call an ionic bond. So the positive and the negative charges attract each other to form a strong chemical bond called an ionic bond. So just a quick example. Here we have sodium, and sodium has one outer or valence electron in its electron shells. Chlorine has 7 electrons in its valence or outer shell. When these react, if we were to react sodium and chlorine, the sodium would lose the electron and that electron would be transferred over to the chlorine atom. So we would form a positively charged cation with our metal and a negatively charged anion with our nonmetal. These guys would then be attracted to each other because of their opposite charges, and they would form an ionic bond between them, which would of course constitute an ionic compound. A few things about ionic compounds. Ionic compounds, also called ionic solids, they don't exist as just one sodium and one chlorine bonded together. They exist as a large collection of the positive and negatively charged ions packed together in a regular repeating structure called a crystal lattice. So if you look at salt, here's some salt crystals over here. If we look at these salt at the atomic level, you would see a repeating array of sodium and chloride ions packed together in a large crystal lattice structure. The smallest piece of an ionic compound, so the smallest repeating unit, is what we call a formula unit. So ionic compounds, the smallest unit is called a formula unit. The simplest ratio of positively charged ions which has no net electrical charge. So put another way, if this is a sodium chloride crystal right here, the formula unit would be 1 sodium and 1 chloride ion, and that would be called a formula unit. If we looked at something like calcium fluoride, CaF2, a formula unit for calcium fluoride would be composed of 1 calcium and 2 fluoride ions. So let's talk a little bit about molecular compounds. Molecular compounds form in chemical reactions when 2 or more nonmetals bond together by sharing electrons between them. Molecular compounds are made when nonmetal atoms join via chemical bond called a covalent bond. So the shared electrons is what bonds our nonmetals together. The shared pair of electrons is what we call a covalent bond. So it's very different than an ionic bond where the electrons are transferred. Molecular compounds are also called molecules or sometimes covalent compounds. So let's look at a quick one here. Here we have a hydrogen atom with one electron, another hydrogen atom with one electron. If we reacted these two hydrogen atoms, the electrons would be shared between the two. They would not be transferred one from another, so we would not have an ionic compound, but we would have a molecular compound where the electrons are shared. This forms a very different type of bond than an ionic bond, but it is a chemical bond, which is, again, very strong. Some examples of molecular compounds, H2O, water, CH4, methane, C6H12O6, glucose, CO2, carbon dioxide. In all of these, you notice that they're all composed of nonmetals, carbon, hydrogen, carbon, oxygen. Any of the nonmetals, chlorine, bromine, phosphorus, sulfur, compose molecular compounds. There are no metals generally in molecular compounds. And it's very important for us to be able to identify and differentiate an ionic compound from a molecular compound or a molecule just based on the chemical formula. As we saw, of course, molecular compounds and ionic compounds, molecular compounds and ionic compounds have very different chemical compositions. Because of this, they're named differently. So we'll look at naming compounds in a little while. And they also have different physical and chemical properties. So just a brief introduction to that. If we have ionic and molecular compounds, the smallest piece of an ionic compound is called a formula unit. The smallest piece of a molecular compound is a molecule. Ionic compounds are composed of a metal cation bonded to a nonmetal anion, whereas molecular compounds are composed of nonmetals which are covalently bonded together. Ionic compounds are generally solids at room temperature, whereas molecular compounds are generally liquids or gases. Now, there are lots of molecular compounds that are solids, but many of them are liquids or gases. Ionic compounds have very high melting and boiling points, whereas molecular compounds tend to have much lower molecular melting and boiling points. And this, again, these differences are because of the different types of atoms and the different types of bonds holding these atoms together. So be sure you can identify an ionic compound and a molecular compound and understand some of the basic differences between those.